Jennifer, would you mind moving us to the next slide?
Yes, I will.
Thank you.
I was getting the chat window lined up.
I totally get it. Hi, everyone. Thanks for joining us today. I'm Chloe. I work with 3C Ren out of the County of Ventura. Before I pass things off to Jennifer and Grant, I have some quick logistical slides to go over. A few quick Zoom reminders before we get started. Please make sure you are on mute for the duration of the training. We definitely encourage questions, and if any questions come up, please feel free to pop them in the chat, or you can raise your hand and we can unmute you. This session is being recorded. The slides and recordings will be shared with you within the next few days. In that email where you get the slides and the recording, you're also going to be getting a survey. If you liked this training, I would really appreciate if you can fill that survey out. It helps us a lot to know what sort of trainings we should do more of or what we should do less of. And the survey will only take you a couple minutes of your time. This training is eligible for both AIA and ICC learning units. We are distributing the learning units based on Zoom attendance. So if you wanted to receive those, make sure you have joined today's call with the link you received when you signed up. And if you have any questions about that, please go ahead and email me. I'll pop my email in the chat soon. Just a few quick words about who we are. We are the Tri-County Regional Energy Network, aka 3C Ren. 3C Ren is funded by ratepayer dollars that we all pay into in our utility bills through the public goods charge. The benefit of being ratepayer funded is that there is no cost to those we serve. And as a regional energy network, we are able to return these dollars back to our local economy, which has historically missed out on some of these funds. You can go to the next slide. Thank you. 3C Ren currently offers 6 programs focused around 3 services. These include incentives, training, and technical support. Our training today is part of our Energy Code Connect program. You can see in orange in the middle here. You can see additional trainings being offered and learn more about our other services by visiting our website, 3c-ren.org. Since 2019, 3C Ren has had over 4,000 individuals attend trainings just like this one today. We have completed over 1,000 energy saving projects. We've answered over 300 Title 24 and Cal Green questions and secured $155 million for investment in the Tri-County region. And we are all so excited on the 3C Ren team to continue growing in all these areas throughout 2025. And with that, I will hand it over to Jennifer and Grant to start today's training.
Hi, everybody. Welcome. I'm glad you could make it. Today, we, like Chloe said, this class will give you learning units, AIA learning units, and ICC learning units. I'm Jennifer Rennick. I'm a licensed architect and certified energy analyst through KBAC, and also do trainings with the 3C Ren. Today is kind of the second in sort of, I'd say, a series. Really, we started out last month with just kind of this big overview of sort of what is the energy code, kind of energy code 101. Sometimes we refer to it. Today, we're going to start with kind of the next phase of that, but leading into the 2025 code cycle. And so today I'm going to go over some just kind of big picture things. It's going to be some definitions and things that they've put in the code. There's a pattern to it, the way this code cycle's kind of rolling out, where there's some new definitions, and then things are better defined, because then the follow-up is it shows in some of the code language. And then to better understand that code language, it helps to understand that they put a definition of some of those terms and some of those things in the administrative part or the first part of the code. And then we're going to look at kind of how that lays out. And then we're going to go over some of the kind of the big picture highlights for the multifamily, single family, and non-residential. We won't go into super detail on everything. We only have, just over an hour now for this, but then we're going to follow it up with a course that's specifically for the residential or single family and duplexes, that kind, then the multifamily and our non-residential. And we're basically going to follow in the order of the way the code's laid out. So the energy code and our building codes are on a triennial cycle, meaning every 3 years they get updated, just in case some folks on the call are not aware of that. And just to be clear that the 2025 building code, even though it's called 2025, it doesn't go into effect until January 1st, 2026. So we're starting now to kind of train folks up to when it goes into effect, January 1st, 2026. And if you apply for a permit on or after January 1st, you'll fall under the 2025 code. If you get everything in before January 1st, you'll still be under the current 2022 code. You can look at these documents. They're in the what's called 15-day and express day language right now, which if any of you are doing plans examining or you really like to dig in deep into the energy code itself, this is a good version to look at because, and I'll show you some excerpts from it because it shows you what is new, introduced, what the old code was, and gives you a good idea of what's changed. So the new stuff is going to be either underlined or double underlined, things that are getting changed or crossed out with a strike through. And then if it's just plain with no strike through, no underlining, that part of the codes remain the same. And then you can get to that. When you go to the California Energy Commission website, I don't know about you all, but I have to remind myself to go to programs and topics, and then all programs, then the building energy efficiency standards. And then from there, I can click on the 2025 building energy efficiency standards. And part of this 3-year process that the CEC, California Energy Commission, engages with industry experts, stakeholders, they go through a process where they do data gathering and what's called pre-rulemaking, and then they have a whole process called formal rulemaking. And that's where we are now, where the formal rulemaking was made and everything was okayed. And now the California Energy Commission is working to tighten up all of the documents before this goes into effect January 1st, 2026. Right now, we're actually in kind of the data gathering and the pre-rulemaking phase for the 2028 energy code. So for any of those of you on the call who want to be a part of those stakeholder meetings or part of those workshops or have input into it, now's the time to get involved with that process. Now, California has been making steady progress and has been on this path since the 1970s with the first Title 24 energy standard. And then in 2008, we started to really talk about energy efficiency, strategic planning. You know, by the time 2020 came around, we were adding PVs to homes, and now we've expanded it to the non-residential occupancies, you know, currently in the 2022 code, in 2023, in 2024. We're going to keep going with that. And then by 2030, we are expecting to have a 40% reduction in greenhouse gas in buildings emissions and a 60% renewable energy generation. And we are already on track for that. And in fact, we're probably a little bit beyond it. And I'll show you a slide of that. And then the idea by 2045 is we have 100% carbon-free electric generation, which is kind of pushing us all towards all electric construction. So currently, In California, this kind of big picture is that our electricity generation, how we generate our electricity, is becoming cleaner. And right now, we use natural gas fired peaker plants, are called. We fire these plants up to burn the fossil fuel to generate our electricity. And right now, that it's only accounting for about 31% of our electricity generation, which is good. That number used to be a lot higher. And now, with our nuclear, hydroelectric, and other renewables like wind and solar, we now have 69% approximately that come from non-fossil fuel sources. So our electricity grid is becoming cleaner and cleaner, which kind of helps us move towards lower greenhouse gas emissions. Buildings use a large part of our electric grid. Transportation, as that becomes more electric, our transportation then will be plugging into our electric grid as well. And so it'll become imperative that we continue to find cost-effective ways to reduce our greenhouse gas emissions in our electric generation. And then with that clean electric generation, we can have more electric appliances, heat pump technology, and start moving towards a building environment that doesn't contribute to greenhouse gases. Now, one thing that California has to do before any of the standards can be approved is by law, California has to show through the California Energy Commission that all the proposed language can be cost effective. And the new standards are estimated to provide about $4.8 billion in statewide energy cost savings. And then part of these big picture goals for 2025 is also to save water and save energy at the same time by reducing the water use in homes and non-residential buildings, because there is an energy water nexus. So if we save water, we save energy at the same time. And specifically, that gets into the plumbing code for pipe sizing and new requirements for chillers and cooling towers. We won't go into those details in this presentation, but when we hit on the non-residential, we'll look at what's required on the chillers and cooling towers, et cetera. We also, with 3C REN, we do have a focus on the Tri-County region, which is Santa Barbara, San Luis Obispo, and Ventura counties. So climate zones 4, 5, 6, 9, and 16. And those, you can learn more about our climate zones if you're not familiar with them in what's called the reference appendices, but also you can go to a new website or relatively new website that the California Energy Commission has put online, and it's called the Easy Building Climate Zone Finder, which I have used, and I think it's quite handy. I love that you can just type in the information and it'll tell you right where your climate zone is. Okay, that I'm going to kind of segue into how the rest of the whole code is organized, because when it comes to the energy code, we have not only our reference appendices that I just alluded to, but we have the standards and manual of the code. And then that code refers to the reference appendices. And so this gives you an example. This is what this looked like for 2022. And I'm assuming that the covers are going to still look basically the same and just be updated for 2025. And you can already get your hands on the draft documents for the manuals and the calculations that go into the software for doing performance modeling, or rather, they'll spell out exactly how you have to calculate all that. So there's 6 documents, 6 books in all that someone like me loves to read. And I hope that because I like to read it so much, and then 3C Ren likes to do trainings, that I can spare some of you. But if you want to dig in, these are the manuals you'll want to take a look at. Title 24, Part 6. It has an organizational hierarchy that's different than the rest of the building codes. There's rumor that structure is going to be changed, or at least cross-referenced for a while before maybe it changes and follows a similar format to the rest of our building codes. But for now, we have a category, we have a subchapter 1 and subchapter 2 that deals with all the occupancy types. And then we've got subchapter 3, 4, 5, and 6 that are specifically for the non-residential portion. Then chapter 7 and 8 and 9 for the single family residential. And then we've got subchapters 10, 11, 12, that's multifamily residential. And for those of you who've been working with the code for a while, you'll recall that under last year's 2022, or last triennial cycle, 2022 is when these new multifamily subchapters were introduced. And that is going to stay, as far as I could tell, will still be continuing that way, where multifamily residential requirements are pulled out of the other 2 categories to simplify things. When it comes time to really looking at the code and all the sections, there is a table at the beginning of, if I go back to the slide here, there's a table at the beginning of subchapter 1 where it's all the occupancy, the scope, and definitions. And that subchapter has this great table called the application of standards. If you're not familiar with it, I just want to show it to you because this is a great means to navigate the energy code. And one of the things that's a little bit different now for the 2025 energy code is that there's some new sections and occupancy categories have been expanded. So this excerpt right here is pretty similar to the old code. You read your occupancy or your, types of occupancy on the far left, then you look at the application, and then it breaks into whether it's a mandatory, a prescriptive, or a performance. And I'll explain those terms shortly if you're not familiar with them. And that all applies, the prescriptive and performance often applies to new construction. And then there is some specific requirements that you would find that relate to being an addition or an alteration that may have its own unique section. With the new code, we now have these new sections of demand responsive, DR controls. And a lot of these have to do with like HVAC zoning or thermostat controls. And so now these have been pulled out separately so that you can cross-reference them and go to those sections or the reference appendices that make sense for what you're looking for. And I think this is great that this table has been expanded so that if you are looking for specifically about the demand responsive controlled receptacles. Now it lists where to go for those mandatory measures, for example, within the code. The part of this table that deals with single family, there's no change to it. And the part of that big table that also deals with multifamily, there's no change in that. That reads pretty much the same. Okay. That was kind of this big structure, introduce you to the tables. Some folks I know this might be a review, and then we've got other people on the call who are also just getting into the energy code and are new to the energy code. So I thought it worthwhile to do that review and to introduce it to new people. There's a few terms and metrics I want to review as well that are going to come into play as we go through the rest of the presentation. Like I alluded to before, mandatory requirements. Those are energy efficiency measures that are applicable to all projects, essentially. And the prescriptive or prescriptive component package. These follow basically a checklist. It's kind of like a recipe card. So if you have a project and you follow all the parts of the prescriptive package, then your project will comply prescriptively. And when you use this way of showing compliance for your building, you need to follow all the parts and pieces of that prescriptive package. And then the mandatory requirements are also apply. Or if you want to do trade-offs and you want to not follow sort of that checklist or recipe method, then you can do the performance or computer modeling method. The mandatory requirements are still applicable, but now you can do trade-offs. So if you do something, let's say you do more energy efficient heating and cooling equipment, you might be able to do less energy efficient walls, for example. And you can trade these things back and forth. The prescriptive component package often is the baseline for the energy modeling approach. Okay, that kind of sums up everything that was a review. Now, really big change to the energy code is the metric that we use when we do computer programming, the computer method, the modeling method, the performance method for showing energy compliance. We had one set of metrics that we've been using for years and years. So if you're brand new to the code, maybe this doesn't matter so much. But for those of you who've been dealing with the energy code for a while, this seems kind of a big deal, in my opinion, that the metric for how we compare our baseline building to our computer modeled building has changed. And it has everything to do with California showing that the things we want to do are cost effective. And it has everything to do with how can we try and get a handle on what the real costs are to the state and to all of us when we use energy. So taking from economics, we're now going to be looking at the long-term system cost, LSC, of all the electricity, gas, natural gas, or propane that's used within the modeled buildings. And so that energy use is going to be converted to a long-term system cost. And it's going to include the energy used for space conditioning, water heating, mechanical ventilation, heating, cooling, etc., like previous cycles. And it'll also include the energy from our photovoltaics and energy storage. and lighting, but we'll have also demand flexibility and other plug loads that are put into this. And there's going to be an efficiency component and a total component. And then source energy is going to represent the long run marginal costs when we look at where does the energy come from. And another term that's going to be flying around is demand flexibility measure. I put this here for you guys to have. You'll get a copy of the slide deck. But really at this sort of point in the presentation, I just want to kind of give everyone a heads up. There's going to be this new metric, and I think it'll take folks a little bit, or to understand what the implications are going to be in terms of how our buildings perform in the performance model. But under the take, for example, under the current code, if you had a small commercial building, we would have used time dependent valuation. We would have measured it in kBTU per square foot per year. And now we're going to be looking at long-term system costs and source energy. So we'll have a long-term system cost efficiency, where we show how efficient the building is, and then we'll have a long-term system cost total, which includes our PV system. And that energy system is going to be looked at over a period of 30 years. And then we're going to have source energy, which is that long-run marginal source energy of fossil fuels that are burnt or combusted as a result of either the building using the fossil fuel directly in the building itself, like with a gas furnace, or if it's burnt or combusted to create the electricity that your buildings use, as in those peaker plants that we use to generate our electricity. And if all three of those components pass, then your building will comply and pass. Okay, the other kind of big picture change, and again, a lot of the code changes this year have a lot to do with these metrics and new vocabulary, new definitions. There hasn't really been that many changes on how we construct the buildings per se, but a lot of new words and vocabulary. So HERS raters, they get a new name. So that's something, it doesn't really change a lot on what our hardworking HERS rater does. They'll still do our duct leakage testing, blower door and envelope leakage testing. They're still going to be doing field verifications for refrigerant charge, exhaust fan, hood fans, et cetera, HVAC efficiency, capacity, and assisting and completing our documentation for final occupancy, the CF2R, CF3Rs, and then the corresponding forms for low-rise residential as well. So now this hardworking HERS rater we'll refer to it as a ECC rater. So basically, HERS was all defined and under Title 20 of our big picture, all the titles that we have in California. So it was actually under Title 20 with the appliance efficiencies. And under the prior code cycles, it's going to still be referred to as HERS for Home Energy Rating System. But now, under the new program, it's going to be ECC for Energy Code Compliance, and we'll have an ECC rater, and they will do field verification, diagnostic testing, but you just kind of don't put the HERS in front of it now, and you'll see an acronym FV and DT show up in the code. Now, all of this is in Title 24. So they took it out of Title 20, they put it into Title 24 in Article 1 in the administrative section. And in addition to that, they also really spelled out more of what the ECC rater is supposed to do, can do, and they've included a quality assurance review and an audit process for the ECC rater, which it means the ECC rater is going to be held to account much more fully than under the old program. And the ECC rater can achieve something called an exemplary status to show that they've gone through that audit process and did it well and are doing excellent work. Let's see, have we had any questions, or is all those questions, everything getting answered well
Yeah, we
in
only
our?
had one bigger picture one, and we don't need to address it right now.
Okay,
I did have a quick just question, Jennifer. Uh,
yeah,
Previous code cycles have come through. I remember when 16 went to 19, there was a huge push to get projects in prior to the 19 code coming out because of the substantial changes and requirement thresholds.
yes.
Whereas 19 to 2022, everyone reacted the same way, freaking out, saying, I better get this in really quick. And 2022 actually clarified, simplified, made allowances for that. In my opinion, the 2022 code ended up being easier in a lot of cases because it properly accounted for some of the new appliances we were seeing. Based on your early overview, would you say that this change to 2025 is one that people need to have anxiety and rush projects to get under 2022? Or is this one that you think it's not that big of a change as compared to other code cycles?
Oh, that's a good question, because I it was taking a look at the new metrics, and in some ways I think it won't change that much, because, for example, um, the natural gas and propane metrics are, if you're using those in your building, you'll, similar to this code, you still have to deal with that source energy.
Yeah.
So it's the code's nudging us towards that cost effectiveness, but like in an economic, terms of long-term cost benefit. And so I think that in some ways it's going to be relatively the same. But what I did notice is that the electric portion of it uh, can vary quite a bit by the climate zone, and it will vary by whether it's a residential, a non-residential, or a multifamily project. And then they have a high and a low based on what it could be, that multiplier based on how and where you get your electricity from. And there's a big
Okay.
range in that. And what I've heard from some of the other folks that have been working on this, and I haven't been able to play with it, modeling it yet and seen it. And maybe it's because of the climate zone we're in is relatively mild, but there's going to be more of a push to steer people away from using a lot of electricity at the peak heat of the day in summer. So they're really trying to look at how do you move away from peak electricity use when everybody needs it.
Hmm.
So there's going to be strategies to move folks away from that. And I think we're
Okay.
going to have to play around with some projects in the software coming up to really understand it.
Well, I'm sure we'll have more information about that as, these things start to get rolled out and we'll have a better idea. I do just remember, and I wanted to make note of it because a lot of people who pushed for that previous code cycle ended up causing themselves more grief than it was worth. So I know we'll talk more and have a better understanding of the actual implications once this gets rolled out in software. That's great. You can continue.
Yeah. And then some of these things we go through, you'll see that in some cases, not in certain occupancy types, really not a lot has changed.
Okay.
So your project will probably be fine if you were already complying, and if you were already meeting the prescriptive compliance and we're doing a little better and small trade-offs, your project's probably going to be fine. But what we did see last year is a big push because people really wanted to have a more energy efficient mechanical and lighting system on the non-res to not have to exterior insulate the walls. That whole dynamic, that hasn't gone away under this new code. That will still come into play big time. Okay, one little change you might notice is that it's little, but it's scope, so it's kind of big, but we don't really address it directly in this presentation. But laboratory L has been added to the scope of the energy code now. So kind of the main takeaway here is that the 2025 energy code updates are intended to add consistency with the other parts of the building code and throughout Title 24. So now laboratories officially L's recognized, and then as such, under the non-residential function areas definition, now laboratory is listed as one of those occupancy types, and it's kind of is explained what it is. And so I put the language, pulled it directly from that definition of the code and put it in here for you as a reference. But I think one thing that might be a little bit different is that it can be a space or room where hazardous materials are used. For example, maybe that's self-explanatory, but also, a laboratory suite is Group L if it's contains, even if it contains office, storage, equipment rooms, or similar function, if it's all part of the building structure, could be part of Group L. And these areas could also include workbenches, scientific instruments, and all the associated floor space with it, for example. Another sort of definition thing that comes into this first part of the code and just kind of clarifying things is this is a new, there's new section. It's been really filled out for the heat pump water heater types being defined. I pointed out because heat pump water heaters are coming on board, coming online into our projects more and more. They're going to get more and more popular. It's an energy efficient way to heat water. Given some parameters, it's still more energy efficient than straight up electric resistance. And then depending how it's used, how it's designed, this is the direction California is going. So there's been some effort in defining heat pump water heaters. And to kind of play into that, like these two units there, I just picked that brand because they were easy to grab just as an icon. There's other brands out there, but when the heat pump and the tank are all integrated, it's going to be called your integrated heat pump. And then all the rest of these on the slide are all a type of split heat pump water heater split system. And now the code's kind of clarifying that if it's a split refrigerant type of heat pump where refrigerant goes in between the outdoor unit, indoor unit, or if it's a split hydronic type of heat pump where water is the vehicle that is used in a hydronic circuit between outdoor units and holding tanks and indoor equipment. And then there's multi-pass and single pass type of heat pump water heaters. So the language is there for you to take a look at, but these are some examples of those things. And then here's an example of a project that we worked on just to kind of show you what they mean by split hydronic heat pump water heater system. The picture on the left shows a roof mounted system where they had the outdoor condensing air to water heat pumps. The refrigerant is contained just in that outdoor unit, but in this particular case, they also had some holding tanks up on the roof and then more tanks inside in conditioned space. And then the picture on the right shows the single pass heat pumps, compressor condensers. There's Sandin or Sanco brand. And then the hydronic circuit or these big insulated water lines that connect up those single pass units, put it into the holding tanks, and then there's a swing or a loop tank, which is electric resistance to maintain temperature. And then a recirc pump can be connected to that. So that's an example kind of those definitions in what it means, an example. The other definition that's showing up now is, and specifically kind of spelled out now, is air to water heat pump, AWHP. And this we'll probably start to see more of as well, but these sometimes also referred to as monoblock units. They use water, hot or cold, that circulates within the house or circulates within the building, and as opposed to refrigerant. And they can use ducted systems to deliver cooling. They could also do that for heating. A lot of times they're ductless or radiant. And this particular Space Pack brand is for their Solstice unit is using a Mitsubishi inverter for a higher performance. So all the refrigerant is contained in the outdoor unit, and then it's using water piping to condition the rest of the space. So they made a point of doing the definition of it because then this shows up as something you can use in the code for your building. Grant, you just came back from a workshop that dealt with something of this. Anything you want to add? I know we're doing code and not implementation yet, but any insights?
I'll try to stay out of the weeds on this one. I guess my thoughts are we're likely going to see more of these becoming available. I don't think there'll be a overnight success where we're going to see them in projects really quickly, but something to be aware of, because in the next coming years, a lot of the major manufacturers are going to be putting out their own versions of them. And the benefit really stems from having this single appliance serving multiple uses, which has impact on the refrigerant quantities, which is a whole other conversation we touch on, and your panel size. Maybe in certain cases, installing multiple electric appliances for your heating, cooling, hot water would require a panel upgrade.
Electric panel.
Yeah, electric panel. A lot of people have shown that using one of these, you can avoid that panel upgrade. So the code's just getting them in there so they are available to be modeled and included. But I don't see it as a standard appliance competing with what we're used to currently for the short term.
Yeah. Okay, and then sort of moving along with the next section of our code is the mandatory measures section. And there's just three sections that have been updated here. The space conditioning equipment mandatory measures, service water heating mandatory measures, specifically in the installation of heat pump water heaters. And then pool and spa systems and equipment installations. And with that, they're just, upping the ante on sizing and right sizing your pool equipment and efficiency upgrades, and then how your supplementary heaters have cut on and cut off controls. And then with the space conditioning equipment, there's some, kind of big picture. Some appliance tables have been removed from this section. You find them in Title 20, or they're referring now to the federal minimum efficiencies and the federal standards. But there are some new tables for heat pump and heat recovery chillers and updated cooling tower water quality and water properties. And what all these have in common is that they're part of that water energy nexus, as many of these changes improve the water and energy efficiency. We're going to just take a look at the service water heating right now for today. And under section 110.3, service hot water, section C is the installation, and we had 6 topics that dealt with mandatory requirements for heat pump water heaters, but now we've added a 7th, specifically the air source heat pump water heaters installation. So some of these were kind of part of the other parts of the codes here and there. Now they've pulled that. It's all here, plus new stuff as we learn more and more about how to work with heat pump water heaters. So this is probably one of the biggest, sections of change that in this part of the code. And so again, I pulled the language from the code for you so you could just have it as a reference. But one of the things that they're just stating overtly now is that if you have an air source heat pump water heater, you have to have backup heat source. And that's because a lot of the compressors, they cut off at temperatures that are really not that cold. So some of the units will stop working in heat pump water heater mode at only 45 degrees Fahrenheit. The newer ones will cut out at 37 degrees Fahrenheit. So backup, and in this integrated heat pump water heater, for example, the backup heat is the built-in electric resistance elements. That's okay. When I worked on another project, multifamily project, I think it was a creative solution. It wasn't explicitly allowable or not allowable under the 2022 code, but the mechanical engineer very much was designing it to have some kind of backup heat source. And so the entire system included another heat pump that was part of the system that could help maintain the air at that warmer temperature to make sure the heat pump water heaters could function properly. And each of these heat pump water heaters, they require air. And so it's referred to as ventilation, but it doesn't mean it's like ventilated, like fresh outside air. It's not that kind of ventilation. It just means that there has to be enough air volume for the heat pump to take the heat out of that air and put it into the water. And then it ejects the cold air because the heat's been pulled out of that air. And so you can see in a very small confined space, it's possible that this appliance would continually chill the air and it would be too cold to function properly. So ventilation is a big part of it. So now they're in these mandatory measures, they're really spelling out that if you have a heat pump water heater with no ducts, you need to follow some, they're putting requirements for how the space can communicate to a larger volume. So in this case, this heat pump water heater was installed in a closet and it's got a louvered door. So it's okay to use the louvered door, but now we have to calculate the net free area of the louvered door and see if it's large enough or follow the manufacturer's specifications on it. And then there's some other qualifications on where those openings can be located. So that kind of ties back into this theme of now the code has included a definition for net free area, specifically for how you calculate it with louvers or slats. So hopefully you would be able to look this up, but maybe the manufacturer of your door or somehow you would be able to verify that you're going to meet this net free area. And it's basically the gap height and the gap width times how many slats you have, right? By inches. And then you would know if you're going to meet that 125, if this 125 square inches plus another 25 square inches per kBTU hour of compressor capacity.
Jennifer,
Yeah.
Julie asked if we can exhaust the cold air being produced from the heat pump water heater and ducting it into the attic. I know this is something that's coming up as people are trying to locate these in really small, locations.
Yeah.
There's definitely rising concerns over introducing condensation from a variety of ways where you're ducting that. And then also that performance of the unit. What are you currently saying when someone says they want to duct this up into their attic?
Some folks have had really good success with it. Depends on your climate zone. We're generally a dry climate, and when you chill the air through your heat pump condensing unit, I mean, you're condensing the air out of it. So yes, the air is colder. It's also drier. So it may be cold air, but it's dry air. And so you would put that dry air up into your attic in the summertime. I mean, that's like the ideal. But
Yeah, but
also,
there is the other hot side of it that you're introducing a colder temp to your attic, let's say, and you could create condensations just by the drop in temperature for other latent moisture in the air. So it's not really a just do it answer. It's not a let's assume a insulated, non-vented attic. So because it's non-vented, um,
a
you know,
non-vented attic.
yeah, we're not that's where it
Okay.
becomes.
Yeah. Yeah. We can help you look at that, and Grant can help you look at that. But what the code kind of, if you maybe take a look at the note down at the bottom, is part of the code language. This is the whole thing excerpted. It does say to really think about it. If you're, for example, ducting only the inlet or the exhaust across the pressure boundary, you could interfere with balanced ventilation systems. This should be considered when specifying heat pump water location and ventilation method. So I'd say that's another thing to kind of keep in mind. And some of the other kind of mandatory requirements is that you're supposed to seal those ducts at the building penetration, and they should be R6 ducts. And then you're going to want to think about the flows of heat and cold and the temperatures, etc. But we've
Yeah, I think the takeaway is just, of course, it depends. And I'm cautious in just saying yes, that's a good solution in all these cases because we have seen a number of instances where people are creating moisture condition concerns just by trying to install these units in really small spaces. So it's hard for me just to say, yeah, that's a good idea no matter what. Um, it'd be a good one for us to talk about further, Julie.
Oh, yeah. And also in this kind of the other thing they're really pushing with these mandatory requirements is to understand also that if you're ducting to and from another space, that you make sure that other space meets the volume requirements, right? And then the cross section of the ducts or the grates or the grills, they all also have to be large enough. So the main kind of big picture on why they put all this in the code now is because these appliances to function properly, to get the high COP, they need volume of air. And they don't work so well if you restrict their volume of air too much. And each appliance is a little different. Some of them need like 1,000. That was kind of the old style, 1,000 cubic feet. Then it was down to 750 cubic feet. Now A.O. Smith has some units that only need 450 cubic feet of volume. So it's, yeah, got to read your manufacturer specs on those as well. Okay, kind of big picture on the non-residential occupancy types, and we'll hit on a couple of these today, is electric readiness now for commercial kitchens is a thing, or part of the code. There's been changes on the ventilation, the outdoor air calculation, which I'll give you an example of. There's now an added animal or veterinary system for the required exhaust fans, or an occupancy rather for the required exhaust fan systems. There's lighting control updates, not a lot, but a few, some demand response stuff. We won't hit on those today. There's been an update on the envelope for the walls and roof ceiling insulation, and then a little bit on the PV and battery. And with the commercial kitchens, again, it's this theme where now new in the code is they took the time to really define kitchen full service, kitchen institutional commercial, and then kitchen quick service commercial. And it sort of spells out what those things really are. And this example of like institutional kitchen where you've got your cook line for a senior living facility. And really where this is going is because we've got now a mandatory requirement for commercial kitchens to have electric readiness in new construction. But right now, the commercial kitchens have to meet the requirements, and it's for the quick service commercial kitchen and the institutional commercial kitchen, not the full service. And with these, you need to have one way is to make sure you have a 50 amp minimum, and your electric panel would have a 800 connected amp minimum, and the electric service panel should be sized to accommodate either the 208 or the 240 volt 50 amp breaker, but that's really kind of a minimum. So for example, this South Bend unit induction, it wouldn't be it wouldn't be unexpected to see this in a commercial kitchen, but if you do it the 3-phase, you need the 51 amps, 1-phase 88 amps. So that's why your branch circuit conductor should be rated at 50 amps minimum. So you might for the engineers out there, maybe think ahead a little bit on that, on what would be appropriate for electric ready, and that would be based on probably the needs of the ownership. And then, of course, if it's already an all-electric commercial kitchen, it doesn't apply. This only applies if you're having gas appliances in the kitchen. For ventilation rates, outside air, the formula has changed. It visually, for any engineers that are on the call, visually the formula looks the same, but they've changed the table 120.1, and now we've got persons per 1,000 square feet density number that we're using. In this case, it's for a corridor. We're just using this example. Let's say we have a 2,000 square foot residential common corridor. We'd have 5 people per 1,000 square feet would be one value we need to look at. And then on this table, we would also need to look at our area-based minimum ventilation, 0.15 CFM per square foot. That number hasn't changed in years, so that's a familiar number. But now we're going to take the larger of those two formulas based on this, those numbers. And in this case, the one formula gives us 150 CFM ventilation required, or 300 CFM. You pick the larger 300 CFM, and then you move on. And so this got this table of values all have changed. If you're doing performance computer method or working with your engineer, they'll figure that out for you. But I want to give you a heads up that that's changed. And then real quick, required exhaust rates. Nothing much has changed except that now they've added these occupancy categories for veterinary and animal holding areas and animal surgeries and cages, etc. And they have their own required exhaust systems. The non-res wall assemblies, the mandatory minimums for insulation hasn't changed, but the non-res wall insulation has increased for nearly all the climate zones. And so I excerpt for you the table just to show you that just about every value on here has been crossed out and a new one put in there and underlined. And that's for your roofs and ceilings at the top two, and then 1, 2, 3, 4 walls for metal building, metal framed. Really, the only one that hasn't changed or didn't change at all was the metal framed walls. And those U values were already indicative of continuous exterior insulation, which is what this image shows of the rock wool insulation over a stud wall, and then with the rain screen cladding on there. So this takeaway, let's, for example, if we take a look at our wood framed walls, and let's just take a look at climate zone 4, that gives us a value 0.053. We'll also do the same thing for climate zone 5, 6, 7. Climate zone 4 also is climate zone 9 and 16 for our county. We have improved values, and what that translates into, if you go into those reference appendices, for example, you would need a 2x6 wall with either R21 or the R20 insulation and an R4 continuous insulation on the wall now to be in compliant with climate zone 4 and 9 and 16. And then for the other, our milder climates, it's still 2x4 wall with just a R13 will work, or if you're in the other climate zone, an R15 and R0 for the continuous insulation. So you have to put a little more insulation in those walls, but not much. Okay. otherwise, most of the prescriptive envelope features really haven't changed much for the non-residential project. The solar battery high-rise, high-rise and non-res, this hasn't changed a lot except that we added the occupancy of library. And in some cases, some of the occupancies have an increased solar and battery requirement. For example, restaurants, which kind of makes sense when we're looking at the commercial kitchens and going towards induction cooking. But also when we look at like resiliency, fire safety, air quality, readiness, or cooling stations for people, libraries are a place people often go. So now libraries have a solar and battery requirement. For single family changes, there's really not a lot of changes in the building itself. But the thing that you can wrap your brain around is like dealing with this new metric of the long-term system costs. And to not be confused, because it is in dollars per square foot, kind of as it shows as a metric, but that's not really an indication of what it's going to cost you to operate your building. It's cost in terms of how California is looking at cost effectiveness across, the impacts of burning fossil fuels and where our electricity is generated from. And so our old energy design rating, that was a score 0 to 100, like a golf score. The lower the score, the better. 0 meaning zero net energy potentially. That's just chuck that out the window, because now it's going to be long-term system cost, or LSCE. And we'll still have an efficiency measure, a total measure, and a source. And how that kind of shows up also in these definitions is real quick. Our energy storage system, they were calling it ESS, but now you're going to see BESS now for battery energy storage system. And they've gone to the trouble to really define now self-utilization credit, or redefined it, because now they're redefining it with the new metric LSC. But what this means in plain English is that if you have a house that you are designing and you go ahead and install the battery storage system, you can get a little bit of credit in that LSC total score that could help your project. And then the amount of credit you get is helpful, but just as you as architects and maybe consumers of this, I just wanted to point out that a battery pricing is still really fairly high, and battery storage is optional, but the solar's required. And there's a learning curve, and we do other courses on this. And I just want to point out that really depending on your personal habits and how much electricity your family consumes will depend a lot on whether you think your battery is worth it or not. In my case, it seems worth it. Other people may not use so much energy, might not be worth it. There's also some new prescriptive requirements, and kind of a big deal on the prescriptive thing, in that gas space heating is no longer applicable for prescriptive compliance. So if you do the prescriptive path, you're going to be a heat pump for space heating. And there is going to be a refrigerant charge verification by that ECC rater. And if you do install ERV or HRV, so energy recovery or heat recovery ventilation for your outside air to kind of go with your ductless heat pump system, for example, then fault indicator display, FID, is required. And then your ECC rater will come out and field verify that as well. And then the heat pump water heaters would also be in your prescriptive requirements. So gas water heaters are only allowed under the performance method. Same thing with gas space heating. So this is kind of the appliance package now you're looking at for your prescriptive pathway, all climate zones 1 through 16. And this is now the baseline for your performance method. And then the windows really didn't change too much. Climate zones 1 through 5, 11 through 14, and 16, they had a decrease in the U factor, which means more energy efficient windows. And I threw this little cost slide down there for you just to say, hey, windows, triple paned, dual paned, more energy efficient. There's a lot of brands out there and the costs vary a lot. So this change in U factor was shown to be cost effective, and just look out for brands that are quality but offered at a substantially less price than some of the brands we're used to seeing in our Tri-County region. They're becoming more and more available. And then real quick on the ADEX, the basically climate zones 8, 9, and 10 got an upgrade, so to speak, for an R38. That's the new requirement. It used to be R30 for those climate zones. Now they have to have an R38 in their ceiling. And then for an unvented cathedral or rafter roof assembly, that now can be a prescriptive part of your package. And then all the climate zones are R38 for that. And then for our multifamily, also not a whole lot has changed. So we've got some HVAC heating, cooling efficiencies that are higher. We have updates to our outside air ventilation on the envelope, really just the little bit of difference in the windows. And probably the biggest thing is that there's something called compartmentalization testing, i.e. blower door testing, that you'll have to have. I think probably I'll start with the windows and then we'll go to the outside air ventilation requirement, because that may be that significant change that the architects need to get involved with. But for the windows, there's really not a big change other than, again, climate zones 1, 3 through 5, 11, and now 13 through 16, they had a slight decrease in their U factor, so a little bit better windows are required. And then they make a point in the multifamily part of the code to say there is an exception to these mandatory minimum U factors, and that's if the project is in a fire hazard severity zone or wildland urban interface. But we understand those windows are that work for these are very expensive, so we're not too sure if we're going to see them. But if you do have a project that can afford them and are putting those windows in, you can get an exception to the energy code. And then gas is still allowable, but we have to be electric ready. So not much has changed from 2022 code, other than there's some updates to really spell out that the water heater for the individual dwelling units has to have a space that's 39 inches by 39 inches by 96 inches. So it's spelled out, you need that quantity of space for the future heat pump water heater. But pretty much everything else is, the same for that portion of it. But central heat pump water heater, ready for multifamily is new. So they added these requirements. So in other words, you can do gas water heating, like is in the image there. It's allowable, but you need to make sure that that space is big enough for the heat pump water heater and the tanks, and you need to provide for the ventilation strategy and the pathways, provide for the condensate drainage, and make sure that there's reserved physical space in the electrical panel or the main distribution electrical switchboard. And then there was quite a bit of new language on balanced ventilation requirements. I put this whole bit of the code in there for you for reference, but the bottom line on this one is that in balanced ventilation system or a supply only ventilation system is what we're looking for in multifamily projects now. So, and when you bring in your fresh outside air with a balanced system, the controls or the filters and everything needs to be accessible. So for example, this energy recovery ventilation unit in a multifamily project we worked on, it was easily accessible by a louvered closet door in the hallway where it was set up. And then just to give you a peek on the inside, what this thing looks like, you've got your MERV 13 filters, you've got your oh, sorry, the formatting on this got a little messed up, but there's a MERV 7.8 filter, and there's a MERV 13 filter that need changing, and there is a HRV and ERV core that needs periodic changing. So that's why you need to put these where they're accessible, because you can get these systems clogged up, especially if you live in an area that's really dusty, or if you got a lot of lint or pet hair or other debris, and then the performance goes down. The way the code used to be written is that if you did balanced ventilation, you wouldn't have to do a blower door test on the individual multifamily dwelling units. But now the code is you either do balanced or supply only, and you do the compartmentalization testing with the ECC rater. So exhaust only, no longer a valid way to bring in your fresh outside air unless you're doing additions or alterations. Then you can still do that. There's just that's kind of runs through the highlights on that, and we have a few resources
we had
and
2 questions, Jennifer.
Yeah.
Before we jump into resources, you mentioned a U factor exception a couple slides ago. And I don't know if you called out if that was only for multifamily or single family.
Was it on the windows? This one, yeah,
Yeah.
this one specifically is multifamily, has that exception. I will have to double check if it's in the single family. I specifically was doing this for pulling this together for the multifamily.
Okay.
And this exception is specifically with section 160.1E is the multifamily code.
Okay.
Yeah.
The second one.
Coach question.
Yeah, it's a good coach.
We'll look it up. We'll look it up for you.
The second one was Julie asked earlier when we were talking about this new metric and the changes for long-term cost. Have you seen, do you know if that's going to change the required PV amount for single family? She's wondering about that small buildings to fall under the 1.8 kW to not require PV. So they haven't changed and I'm not sure, but they haven't changed that exception, so that'll remain. So the only reason that this would change is if the calculation for how much solar is required has been altered by the changing of that metric.
Well, I mean, that good rule of thumb, right? The solar, it prescriptively, it spelled out how you're supposed to do it. So that prescriptive becomes your baseline. And so it really depends on the rest of your building if it's going to be different than that prescriptive requirement because the PV shows up under your total score. So it just it
So I don't think
I'm
it
not
will.
expecting it to really I'm not expecting it to change much, but
Yeah, I wasn't expecting it to either, but I thought maybe you had seen it. If there are changes, it would be all the way into like how it's being modeled, not that the 1.8 exception will go away or that those homes are going to be like a smaller home is now going to have to require over 1.8. I would imagine it's going to be very similar.
yes.
Okay.
That's my understanding. The only thing I saw was some of the folks who were really digging into this deeper, and they were highlighting how the for those climate zones that are impacted by peak summer day air conditioning loads, like some of those things were coming into play that potentially was changing their project from what they normally, or what we think of, quote, air quotes, normal, like what we're doing under the 2022 code. So that was that. So far, that was the thing that I learned from others who are in more extreme climate zones than we are.
Okay, perfect. That's all we had.
Okay, then I'll go back to the resource blueprint from the CEC energy.ca.gov. I like it because there's a lot of common questions and answers from a code enforcement point of view. So that's a good resource. And then now, just to kind of FYI point out that Cheers, for those of you doing residential and multifamily work, Cheers is our, PERS provider, soon to turn into our ECC provider and ECC registrar for that documentation. And so here's a link to that. And of course, our Code Coach service through 3C Ren. It's free for everybody, customers, builders, plans examiners, general public. If you live in our Tri-County regional area, then we have a Code Coach service for you. And with that, I'm going to turn it back to Chloe to talk about some of the upcoming courses. And if we have a few minutes and any more questions, Grant and I are happy to answer them.
Thanks, Jennifer, and thanks, Grant. That was really great. You guys are always so great at really breaking down all of this complicated material. So really appreciate having you here for that. And to leave time for questions, I'll go through this quickly. Thank you for everyone who came today. I hope you guys enjoyed it. If you did enjoy it, if you didn't enjoy it, let us know. We're going to be sending you a survey probably next week sometime. It'll be in the same email with the slides and the recording of today's training. The survey will only take you a couple minutes to fill out, and it really does help us decide what kind of training we're going to offer in the future. So if this was helpful, definitely let us know, and we'll see more content like this in the future. If you have any questions about receiving your learning units for AIA and ICC, please reach out to me sooner than later. If you're concerned that your attendance wasn't counted, or if you didn't register for this training and joined with someone else's Zoom link, or if you called in, just go ahead and let me know you were here and I'll make sure you get credit. And then lastly, we have several upcoming courses that you all may be interested in, including what energy consultants need to know about HERS, soon to be ECC, on 2/19, and a contractor connection hub at Beacon Building Products on March 5th. And you can sign up for these trainings and see more being offered on our website. And with that, I can hand it back to Jennifer and Grant to answer any questions we have.
Yeah, please. Thank you, Chloe. Please send in any questions you have right now. If you have ones that come up later, use the code coach service and we can get back to you quickly. Jacob asked the 39-inch by 39-inch floor plan space requirement for heat pump water heater. I'm assuming you're referring to the electric ready requirements for new construction. So if you install an electric appliance, electric equipment, that electric readiness requirement is not applicable. You don't have to do it because you're already installing that appliance. So that would apply to water heater, furnace, a range, and a clothes dryer. I'm referring back to 2022 code. Jennifer, correct me if something's changed. If you're installing a Senko unit, the split heat pump water heater we were messaging about, that would be an electric heat pump water heater. So no, you would not need that electric ready floor plan space requirement. The unit itself, the interior aspect of it is just the tank and connections. So you can fit those in smaller spaces because they don't need to be serviced in the same way. And they come in a wide variety of tank sizes, including crazy custom ones. So it gives you a lot of flexibility when you use those systems. No problem.
Yes.
Any other questions, send them through. We're always happy to stay on longer if people are engaged. Otherwise,
I'm scanning to see if there was any question that we didn't really go over. I
couple
thought I
minutes of
saw
silence
one.
and we'll sign off, but please feel free to chime in and you're welcome to unmute and ask a question that way. We don't mind.
Yeah, and so just kind of the upcoming courses. So the non-residential one, you know, to the 2025 code update, it's going to be in March. And then we'll be doing the multifamily and single family, and we'll keep going like that with talking a little bit more about implementing the code, but we'll be hitting on those 2025 code updates as we go. But you can see from a lot of the kind of the vocabulary, the definitions, kind of the goals, it's sort of setting the stage for really defining these things, because this is the direction with the heat pump technology, better indoor air quality and ventilation. That's the way the code is going. And it seemed like in prior code cycles, we had moved forward with a much better envelope. So insulation windows. So now we're just tweaking those as people get used to building that way. I'm curious though, in our area, I think folks still are looking for ways to use the performance method to avoid exterior continuous insulation on their wall assemblies. But that would be one area that might be harder and harder to avoid.
Yeah. Yeah, I anticipate a big chunk of HRVs showing up to get out of that.
Right. And then some of the other energy consultants I know were saying they're going to be playing around with the self-utilization credit, i.e. adding a battery and more PVs and seeing what that gets them. Yeah.
Yeah, there's always a lag time between when we start addressing these code changes and then the actual when they release the software and finalize it. and actually manipulating that performance model and seeing how the results and bugs and everything else. So I'm sure there'll be a lot more discussion on how things are actually calculating out once that work starts. But right now we're really just focused on the code items that are coming out that we're aware of. Joe asked when we think the software is going to be released. I believe they have like beta versions of it, right, Jennifer? But it won't be approved till near to the end of the year, right?
Right, they've got the right. So if you want to play with CBEC Res, CBEC Com, then you can play around with the beta versions. But like if you're like to use Energy Pro or something else where they're taking that engine and running it, that won't be out for a while.
Yeah, it's always kind of an 11th hour software thing. Seems to be the typical track record.
I think we're hit 11. Shall we close out?
Yeah, that's fine. I'm not seeing a whole bunch more questions. So again, everyone, thank you. If you come up with questions, use the Code Coach service, and we look forward to seeing you guys in future events and trainings.
Thanks, everyone. Have a great rest of
Thanks,
your day.
everyone. Yeah, thank you.